Let's look at another application with rational expressions, and that is work problems. And this will be part 1. Let's consider the following problem. We have Wayne, who can do a job in 9 hours, while Susan can do the same job in 5 hours. How long would it take them to do the job if they work together? In the job, or perhaps we have a pool which is filled by 2 pipes. So all of those can be classified under work problems. So for work problems, we also have a rate. So we're going to be talking about the rate. We're going to be talking about time, and we're going to be talking about the amount of work done. So the amount of work done is going to be the rate times the time, the rate at which the person works or the machine works, whatever the problem is, times the time that is spent doing that. In this particular case, and in many work problems, you're going to have 2 different people, 2 different machines, or 2 different pipes, etc. And so again, we want to organize the information. Here we're going to have 2 people. One of them is Wayne, and the other one is Susan. We're told that Wayne can do the job to do the job. Individually, if Wayne worked, he would work 9 hours to complete the job. Susan does the job, the same job, in 5 hours. Notice that in many work problems, as in this one, it says how long would it take them to do the job if they work together. So let's have another row for the together part. If they work together, how hours? Now, the second column is going to be the rate. If Wayne does the job in 9 hours, in 1 hour of time, in this case we're talking about hours, so we're going to use 1 hour. In 1 hour, he will do 1/9 of the job. Susan takes 5 hours, so in 1 hour, she will do 1/5 of the job. Together, it takes them X hours to do the job, so in 1 hour, they will work 1/X hours. But actually, for this particular method that I will show you, we're not going to use this part right here. Let's look at this part over here. In the third column, we're going to say part of the job done in X hours. Wayne does 1/9 of the job in 1 hour, so in X hours, that's 1/5 of the job in 1 hour. So in X hours, she will do 1/5 of the job. Now let's go to an equation, and we can do the equation in the following way. A part of the job done by Wayne plus the part of the job done by Susan equals 1 complete job. So we know that the part of the job that's done by Wayne is X over 9. The part that's done by Susan is X over 5. Together they will do 1 job. An equation which involves fractions. So let's multiply by the lowest common denominator both sides of the equation. 45 times X over 9 plus X over 5 equals 1 times 45. We can 45 times X over 5 equals 45. But because it's the lowest common denominator, we can say 9 goes into 45 5 times. We have 5x for the first term. 5 goes into 45 9 times. So we have 9x for the second part, and this is equal to 45. On the left, we've got 14x equals 45. X then is going to be equal to 45/14. Remember what x is. It's the time that it takes both of them to do the job. If we solve for x, we're going to end up with x being equal to 3 and 3/14. And it would be a good idea for you to check your work by going back to the problem and seeing if it indeed work problems. Then we're often going to have two people working individually and then apart working when they both work together. Label your unknown. Be the number of hours for both to complete the job. Once we have that, we fill in the third column, which is part of the job done individually. Then we come to an equation. We solve the time it takes them to do the job together.